Right. So weekly review part number 2. The first question now, this weekly review is from the last class. The things we did in the last class, I summarize it into a question set. So let's look into this. Draw the resonance hybrid for the molecule HSO3 minus. First of all, the Lewis structure for HSO3 minus. Okay, the hydrogen is attached to another oxygen. So this is the Lewis structure for HSO3 minus. Now this will undergo resonance to form another stable compound. Another stable structure compound නෙමෙයි. Like this. So both of these are stable. තව එකක් අඳින්න පුළුවන් which is unstable from this, like lone pair to pi bond, then pi bond to lone pair. Then you will get a positive charge on oxygen which is unstable, so you can't take that one. So the resonance hybrid will be a combination of these two structures. What you do, you overlap. You overlap, and then you show the sigma bond, and the pi bond is going to change location between two places. So you draw a broken line and put the lone pairs, then oxygen, and then hydrogen. There are two ways which you can draw. The first method is putting minus half here and minus half here. That's also fine because minus charge is divided into two locations. So it's minus half, minus half. Or you can draw like this. You can put a square bracket and then put -1 here. That's also fine. Hari? That's also fine. So this is the answer for the first one, HSO3 minus. Next one, HSO42 minus. HSO42 minus name, HSO4 minus, sorry. It's like this. Right. Now, there are three structures which you can draw for this. Hari? There are three structures which are stable. It's the first one, sorry, second one, and the third one. This is the third one. Now when you overlap all the three structures, you can see there will be a pi bond which changes location like this with the oxygen. And the charge now, people, there is a total of -1 charge divided into three locations. So you can put -1 over 3 here, -1 over 3 here, and -1 over 3 here. So that's correct if you draw it like this. Also, you can draw it the other way. Just put a square bracket and put -1. That's also fine. So this is the resonance hybrid for the molecule. Then next one, third one, C2O4 oxalate, C2O4 minus. The molecule is like this. Now I won't be drawing the resonance structures for this, but you can see there are 4 stable resonance structures that you can draw. හතරක් තියෙනවා people. When you overlap them, you can see them. Overlap කරහම බලන්න පුළුවන් the resonance hybrid. The pi bond is between all the 4 oxygens. It can exist between all the 4 oxygen like this. Sorry? And the minus charge can be divided into the 4 oxygens. There is a -2 total charge, so it can be divided into 4 oxygens. Or you can put a square bracket and put here -2. That's also fine. නැත්තම් මෙහෙම දාන්න බලන්න -half, 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 and -half. Don't forget to put the lone pairs, hari? Lone pairs of electrons, don't forget to put them. Otherwise, it's wrong. Right. Then next question. I'm moving quickly, people. You can stop the video and watch. Hurry, you can stop the video and watch. Hc2O4 minus. Now the difference is that there is a hydrogen attached to one oxygen. So you can't make a double bond here. ඒක තමයි කියන්නේ. It will get a positive charge if you put a double bond there. So the amount of stable structures that you can draw here, the amount of stable structures that you can draw here will be 3. There will be 3 resonance structures that you can draw. So when you overlap them, you can see now the oxygen here doesn't have a pi bond. It doesn't have a pi bond. So you can draw a dotted line here and dotted line here and dotted line here. Now, what's the charge that you're going to put? The total charge is -1 now. Harida, because there's only -1 charge here. එකයි තියෙන්නේ. So -1 charge divided into 3 locations. So -1/3 කියලා you can put to each of these atoms. -1/3, -1/3, -1/3. එහෙම දාන්න පුළුවන්. That's also possible. Also, you can do it like this. Put a square bracket as before. Square bracket and put -1. That's also correct. My bad. People, I did a small mistake there. Oxalate වල you can't draw structures. ඒ කියන්නේ the resonance structures you can't involve this one නේ. ඇයි බැරි? You can't break the bond and create a bond. හරිද? දැන් බලන්න මේකේ හදන්න පුළුවන් lone pair to pi bond to lone pair. That's possible. My bad. Sorry. You can draw a structure like this. Small mistake there. හරිද? Only these two structures can be drawn. අනිත් එක use කරන්න බෑ people. You can't use this bond. හරිද? You can't use that bond and it will not undergo resonance. It will not undergo resonance. In Hc2O4 minus. හරිද? But in the previous one, this C2O4 2 minus, I was correct. එතන අවුලක් නැහැ. මෙතන පොඩ්ඩක් වෙනස් වෙන්න ඕනි. හරි? මෙතන පොඩ්ඩක් වෙනස් වෙන්න ඕනි. So the resonance hybrid will look something like this. මෙතන double bond එක මේ permanent double bond. It won't change. There's a permanent double bond here. In this location, permanent double bond. And other two locations, you will have a uncertain pi bond. Again, a pi bond which can change locations. So the charge is -half. Not -1/3, -half. Because the double bond can only change between two locations. Double bond can be changed in between only two locations. So therefore -half. That's a good question. It's C2O4. Next one. SO4 2 minus. Now SO4 2 minus, there are many resonance structures that you can draw. Actually, there are 10 resonance structures that you can draw, including the unstable ones. That's not what I want. I want to draw the resonance hybrid. So you can see here the pi bond is changed between all the 4 locations. Pi bond is changed between all the 4 locations. මෙහෙම. And the total charge is -2. So you can put a square bracket and put -2, or else you can divide the -2 charge in between all the 4 atoms. So -2/4 නැත්නම් -half කියලා දාන්න පුළුවන්. -half for each of the oxygen atom you can put. -half, 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 -half. That's also possible. Just divide the total charge into the atoms. That's also possible. That's SO4 2 minus. Next one, IO3 minus. Now the resonance structure, one, two, three, four, 5, 6, and 7, something like this. So you can see there are 3 resonance structures that we can draw, and the resonance hybrid will be like this. the minus charge, or you can divide the minus charge into the 3 atoms accordingly. It's the resonance hybrid. Second one, state whether the following statements are true or false. Pi bonds are always formed by lateral overlapping. That is correct, people. Lateral overlapping only can form pi bonds. Linear overlapping will never form pi bonds. It will only form sigma bonds. Pi bonds can be formed by hybridized orbitals. No, hybridized orbitals always form sigma bonds. I told you hybridized orbitals can't form pi bonds. Only lateral overlapping can form pi bonds, which are non-hybridized orbitals. That's wrong. Sigma bonds are always formed by linear overlapping. That is correct. Sigma bonds are always formed by linear overlapping. I told you it before. Sigma bonds can only be formed between two hybridized orbitals. ඒක නම් වැරදි. Now you can see in CH4. In CH4, people, carbon hydrogen bond. He is using the 1s atomic orbital and he is using the sp3 hybridized orbital. So you can see hybridized orbital and atomic orbital together. So that's wrong. The fifth one, maximum number of bonds between two atoms is 3. That is correct. There can be 2 pi bonds and 1 sigma bond. Bonds hatarak nෑ, people. Never it can form 4 bonds. So it's correct. Hari, yeah? Then sixth one, the maximum number of sigma bonds that can be formed by an atom is 4. වැරදි. Because sulfur. Xenon, දැන් අපි Lewis structures and ඔච්චර හරිද? Sulfur and all can form 6 bonds. Sulfur can form octahedral geometry, people. 6 bonds. An atom can form 6 bonds. That's possible. Not only 4. හරිද? ඒක වැරදි. That's wrong. Then seventh one, the bond between hydrogen atom and bromine atom in HBr is a polar covalent bond. That is correct. H and Br, they have electronegativity difference. So therefore you can tell it's a polar covalent bond. That's correct. Then ozone exists in a resonance hybrid of 2 resonance structures. So ozone molecule, so I gave this as homework also, ozone molecule. To draw the resonance hybrid, I'll do it here itself. Minus plus. Hari. මේකයි තව එකක් තියෙනවානේ. The double bond can move to here, the double bond can move to there, and it will exist in another resonance structure. So these will undergo a resonance hybrid and you get a resonance hybrid. The ozone exists in a resonance hybrid of 2 resonance structures. That is correct. Pi bonds are formed only by lateral overlapping of p orbitals. වැරදි. Sometimes d orbitals can also form what you call pi bonds. That's wrong. XeF2 is sp3 hybridized. XeF2. Now XeF2 කියන්නේ 1, 2, 3, 4, 5, 6, 7, 8. This is not sp3 hybridized, people. When we count the VSEPR pairs, you can see 1, 2, 3, 4, 5. There are 5. මේක හරිනම් this is out of syllabus. මේක sp3d2. හරිද? sp3d2 කියලා කියන්නේ. sp3d2. එවනට ඒක අපේ syllabus එකේ නෑ. However, this is not sp3. If VSEPR pair is 2, then it is sp. If it is 3, then it is sp2. If it is 4, then sp3. If it is 5, sp3d1. ඔහොම යනවා. හරිද? We don't have others in the syllabus. හරි. So that's wrong. That's wrong. Then the third one, state whether the following statements are true or false regarding electron gain energy and electron affinity. Okay, now you have to revise yourself on electron gain energy and electron affinity again. Electron gain energy increases negatively across the period. So when you move from left to right across the period, electron gain energy becomes more negative. And that's correct because chlorine is larger. Chlorine has a larger electron gain energy than what? Sulfur. And phosphorus and silicon. When you go from left to right across the period, the negative value increases. That means it becomes more exothermic. More exothermic, more negative. How is more exothermic, more negative? That's correct. Electron affinity decreases down the group. Or electron affinity කිව්ව first of all, you have to remember electron gain energy. ඉස්සෙල්ලා electron gain energy ගැන හිතන්න. Now people, electron gain energy, what will happen when you go down the group? It will decrease, right? අර exceptional variation එකක් තියෙනවා. ඒක අමතක කරන්න. period 1 and period 2 exceptional variation. That zigzag variation I told. ඒක අමතක කරන්න. Forget that. Overall, when going down the group, what will happen? The electron gain energy will decrease. Electron gain energy will decrease down the group. පල්ලෙහාට යද්දී අඩු වෙනවා. හරිද? අඩු වෙනවා කියන්නේ මොකක්ද? කියන්නේ උඩ -1000 නම් යට තියෙන්නේ -400. ඒ කියන්නේ අඩු වෙනවා කියන්නේ නෙගටිව්ලි අඩු වෙනවා. නෙගටිව්ලි අඩු වෙනවා. ඒත් අර නම්බර් ලයින් එකක් විදිහට ගත්තාම නිකන් it will become closer to zero නේ. That means increase කියලා ගන්න පුළුවන් positively. ඒ කියන්නේ අර හිතලා බලන්න ඕනේ common sense. හරිද? So negatively decrease. ඔය negatively decrease එකට තමයි electron gain energy decrease කියන්නේ. Right? They say electron affinity decreases down the group. Hari, what is electron affinity now? එතකොට electron affinity කියන්නේ මේකේ opposite එක +1000. This is +1000 then. +1000 and this is +400. +400. So it is decreasing down the group. Electron affinity is decreasing down the group. එහෙම කියන්න පුළුවන්. Make a positive value decreases down the group. Hari, positive value decreases down the group. That is correct. Electron affinity decreases across the period. I told you electron gain energy. Think from electron gain energy. Electron gain energy, what will happen? Increases across the period. ඒ කියන්නේ negative value එක වැඩි වෙනවා. For example, -500. Next element might be -560. Next element might be -590. ඔහොම යනවා. From left to right across the period. Electron affinity කියන්නේ the opposite of it. So +500, +560, +590. So you have to think the opposite way, positive way. So electron affinity decreases across the period. That is wrong. You can see it increases across the period. That's wrong. Electron gain energy of fluorine is more negative than chlorine. That's wrong. The zigzag variation. I told you chlorine is has more electron gain energy. That means more negative than fluorine. That's wrong according to zigzag variation. Second electron gain energy is always endothermic. That is correct. Once you remove once you give one electron, giving another electron is hard. Always hard. Always it's exothermic. Second electron gain energy is always endothermic. That's correct. Then sixth one, electron affinity of all elements are endothermic. Electron affinity of all elements are endothermic. That's wrong. For example, now nitrogen and group 2 and group 18 in one. Nitrogen, group 2 and group 18. These elements, people, they have positive electron affinity. Sorry, electron gain energy. Positive electron gain energy. When it comes to electron affinity, it's the exact opposite. So negative electron affinity. Sorry, electron affinity is exact opposite. So it's negative. So exothermic electron affinity. So electron affinity of all elements are endothermic. That's wrong. Then seventh one, nitrogen has a positive electron gain energy. That is correct. That is correct. Magnesium has a larger positive electron gain energy than sodium. Larger positive electron gain energy. That is correct. Actually, magnesium belongs to group 2, which is having a positive value for the enthalpy change. So that's wrong. Sorry, correct. That's correct. My bad. That's correct. හරි මම මේ quantum numbers වලින් පොඩි එක්කුත් දුන්නා නිකන් මතක් වෙන්න කියලා. Which of the following atoms has n squared minus l squared is equal to 5? Now you have to check with all the atoms here. First, let's check for sodium. Now sodium n value is what? 3 ne? Sodium is in the third period, so n is 3. N is 3. L value is 0 ne? Because it's in the s block. The last electron only they are talking about. So 3 squared minus 0 squared is not 5 ne? Again, that's wrong. Calcium is belonging to the fourth period. So n is 4. 4 squared is 16 and L value is 0. So that's also not possible. Then third one is oxygen. Oxygen belongs to second period. So n equals 2, L equals 1 ned, because oxygen is in the P block. P block කියන්නේ L equals 1. So 2 squared is 4. 4 minus 1 is 3. That's also not an answer. Manganese. Manganese is atomic number 25. That means n value is 4, right? It's in the fourth energy level. It's in the fourth energy. Sorry, not in the fourth energy level. N equals 3 people. Aye. Now, D electron පුරවන්නේ. The last electron is the D electron. So last electron, D electron කියන්නේ you have to fill N equals 3 again. 3D ni fill කරන්නේ. So N equals 3 and L equals 2. That's how you take. Hari, L equals 2 and N equals 3. එතකොට you can tell N squared. 3 squared is 9 minus L squared කියන්නේ 4. 9 minus 4 is 5. This is the answer. Let's look at chlorine also. Chlorine people may... Chlorine belongs to the third period. So third period N equals 3, L equals 1. So 3 squared is 9, 9 minus 1 is 8, not an answer. So answer is answer number 4, manganese. Right, so that's the MCQ training session. Now people, may you guys... So now you guys have to do the homework. I gave you some small homework last week. I couldn't discuss it in the class. Ozone resonance hybrid, I drew it for you. Hari, ozone resonance hybrid. Where is it? Right, homework people, HSO3 minus, I drew it here. I did it here. PO4 3 minus, phosphate molecule. Minus, minus, minus. So there's a minus 3 charge. Hari. So the resonance hybrid people, the pi bond is divided into all locations equally. And minus 3 charge, we can write it on top. This minus 3 charge, or else you can write divided into all the 4 atoms equally as minus 3 or 4. That also can be done, and that's correct. Then next one I gave you as homework, nitrate. Nitrate molecule minus minus plus. So it's easy. Just the same thing again and again and again. You just put the sigma bond and then the dotted line, dotted line, dotted line. So nitrate molecule minus 2 charge. Right. Ozone molecule. Ozone molecule. Now there are 2 resonance structures for this. There are 2 resonance structures for this. So when you draw it, the total charge is 0. There is no overall charge here. Don't forget that. There is no overall charge in the molecule. There is no overall charge in the molecule. So you can draw the resonance structure just by putting a square bracket. This is the resonance structure for ozone. So this is the resonance hybrid of ozone. So with that, the weekly review part number 2 discussion is over. Hope you have a safe week this week. It's going to rain again, so every one of you stay safe. Hope to see you in the next class again. Right.